Welcome back to today's video, and in this video we'll be learning the key thing that every programmer as a good problem solver should know, and this key thing is what we call the algorithm. So let's look at this example. When we want to make a call to a friend, someone may just decide to first type the number and give out the call. Another person may also say, oh, I already have the contact, so let me just set the name and call the person. So at the end, we are all looking up to calling someone, but we all use different approaches. So this is what we call the algorithm. So algorithms are the finely defined steps that a programmer uses to solve a particular problem. So in each step there is a command. So maybe say first step I have to do this, second step I have to do that, and the third step I have to do that thing too. So in our problem solving activities, we all go through steps. In our daily lives, we all solve problems too. So maybe say when you want to cross a road, you have to first look at your sight, then before you decide to cross the road. Or when you want to take a shower, I don't think you have to dress up before you take the shower. You have to go through a series of steps. And also when you want to chat someone on WhatsApp, you have to open the chat WhatsApp, you have to search for the chat, open, and that's not all. You have to type the message and press the send button. It wouldn't do it automatically for you because the developer understands how you want to solve the problem, or it's not only one person that you'll be chatting with. So he gave you the chance to search through the chat and select the chat that you want to make. So this is what we basically call algorithm. So let's look at the types of algorithm. We have the series algorithm or the sequence. So this one is going to take action in every step. You say when you want to take a food from the kitchen, it's like wake up, then go to the kitchen, pick up the food. So that was by actions or by sequences. And we also have the selective algorithm, and this is when decisions are made. So when you go to the kitchen and there is no food, you have to prepare some food for yourself then before you eat. So we also have the type of algorithm called the iterating or the looping. This is when a series of instructions are repeated before a certain condition is met. So when you say I want to finish my food before I leave the kitchen, so if the food is not finished, you are not leaving the kitchen, and that's when you want to repeat a particular a series of instructions. So when all these come together, that's when a programmer is able to solve his problem successfully. Or this is the approaches or the means by which a programmer decides to solve his problem, and everybody have a way of doing his things. So that's what we call the algorithm. So we can be asked to create a simple program that allows a user to input the name of a friend. So with our algorithm, we are going to create a program that allows a user to enter the name of a friend. So we give it a title of name of a friend. So the first step we're going to do is to start our program. So with everything we have to start. Then the second step is to accept input. So we're going to input what? We're going to input the friend. So input friend, the name of a friend. So is the name. And the third thing we're going to do is to print out the name the person entered. So we're going to print the name. So it will print the name of the friend. Then the fourth thing we're going to do is to end the program. So with the algorithm that we wrote, the basic thing each and every algorithm should have is the start. It should also have an end. It should also have at least one or two inputs. So that's the basic thing each and every algorithm should have. Algorithm should have at least one input and output. And with everything that you do, you have to start, and your program cannot run forever. So you have to go to a point that you have to end the program. And also, I made this thing name because it's going to receive the inputs the user is going to type. So this name is actually a variable, and variables are containers that are used for storing data types. So if I'm looking for my hot tea, maybe I have to go to the coffee maker or the coffee mixer. Or if I'm also looking for my cold drink, I have to go to the fridge. So this is the situation. I can't have my hot tea in my fridge. So this variable is declared to hold a specific data, so that when we are searching for it, we can just key it into the memory, then it will fetch the data within that container for us. So we can even just create a variable here using our Python. Okay, so let's say a variable a So variable A is equal to 1. Let's say 1. Then variable B is equal to 2. Okay, so we can print the variable B. So print variable B, then it's going to print 2 for us because it's holding the data type and a value, this value 2, so it will print 2 for us. We can also make the assignment method, so we can say A equal B. Then let's try to print the A. So printing A will give us this. It will give us 2. Right now it's no more 1, it is either 2 because we've assigned it to this variable. So if you are looking for the variable A right now, we are having the value of 2 because we assigned it. So this is how variable works, and in the next video we're going to dive into the variable declaration and how we're going to perform arithmetic operations on them. Okay, so with the algorithm we just created, we can have a simple program for it. Okay, we say we're going to input the name of a friend, so name is equal to input. So we bring our control statement and say enter name. Then we say what's the name, so it's requesting for name, so we type out the name, let's say Ishan, then that's it. We can also say print the name, then we have to print the name we declared or the name we called, that's Ishan. So that's how the variable also works here. So this is a simple program we use to requested input data, which is name from the user, and display the name to the user. So that's the simple algorithm we just wrote here. So the name of a friend, we started our program, we took an input from the friend, then we typed the name of the friend too. So that was the algorithm. So we can also be asked to create a simple program to compare ages. So let's say we're going to start, then 2, we're going to say maybe Kofi is equal to 21. Then let's just say Abina is equal to, let's say, 20, and we're going to declare our condition. So that's another type of algorithm. So this is the branching one, or the decision taking algorithm. So we say if Kofi is greater than Abina, then what should it do? It should print Kofi is greater. So print, else what should it do? That's another step. So this 5, we say else it should print Abina. Then we have to end the code, so end the program. So we say we start our program, say Kofi is equal to 21, Abina is equal to 20, and we declare a condition. So in a branch algorithm, we say if Kofi is greater than Abina, then it should print Kofi is older, else it should print Abina is older. So this is also the branching side of algorithm where decisions are taken. So in our code, we can say we're going to declare the variable Kofi. So Kofi is equal, let's say, 21. Then Abina. So our condition comes here. If Kofi is greater than Abina, what should it do? So if Kofi is greater than Abina, it should print Kofi is older. Then else. So if the condition is false, it should print Abina is older. Okay, so it says Kofi is older. Why? Because the variable Kofi contains a value that is higher than the variable Abina. Kofi has a value of 21 and Abina has a value of 20. So this is the code that we just wrote for the algorithm we declared here. So this was algorithm, and this was the programming language. We use Python. So we're going to learn that one later. So we can also be asked to write the loop or the iterating method for the algorithm. That's when a condition will be repeated until the condition is meant for. So we can say 1, then we start our program. We start, then 2, say while condition is false, then it should do it. It should do what we want it to do. So it will continue doing it. Else, if the condition is meant for, it should stop. Else stop. Then we're going to end it. Okay, so this is going to be the looping condition or the looping algorithm. So let's try it here. So we move to our Python terminal now. Then we say while, okay, this is not going to end. So let's say a is equal to 5. Then we say b is equal to 0. Then we come here and say while a is greater than b, then it should do something for us. So it should print a, let's say, okay, a is greater. Then you have to increase the b so that at each step or in each condition it will be increasing, so that the condition wouldn't remain the same, but it will be changing, so that when they are the same, the condition will be meant for. So we can say b is equal b plus 1. So b plus 1, so it's going to be increased by the value 1. Okay, so let's see. Then you see it printed a is greater. How many times? 1, 2, 3, 4, 5. Okay, so that's because a is 5 here and b was first 0. So we told it to increase b by 1, and by each increase it should print a is greater. So until the condition is meant for, which this condition a wouldn't be greater than b, it should be printing a is equal to greater. So that's the looping or the iterating form of algorithm. So it's going to repeat itself until the condition is meant for. So these are some of the operators that we use in coding. So we have this, the addition, the subtraction, the multiplication, that's the asterisk. We have the caret for exponent. We have the percentage for modulus. We have the backslash for division, and a lot. So these are what we're going to be looking at in the previous next video. So this is also like the equal sign. It's used for assignment. These are also used for assignment, and this is used for checking if the value of two variables are the same. So these are some of the things that we'll be using in the next video. So all algorithms should have the start and the end. They should also have at least one input and output, and the variables that are going to be used in the program should be declared before they are called. So you can't say print b while you've not declared b, or if you've not accepted any input from the user and assigning it to the variable b. So to do this, we have to always create our variables before we call them in the operation. So in representing algorithm, we can use the natural language, which we've already done. We can also use the pseudocode, and we can use the flowchart. So the pseudocode is when you use the English word in short forms and the aspect of programming language. So we can say we will create a player. So player, we create a player, and we say if gun, or if the bullet hits the player, if the bullet hits player, what should it do? It should do something for us. So you say the blood should be -1. So blood is equal to blood -1. Then we can also say if the blood, so if this blood equal to or equal 0, that comparing the variable equal 0, then it should do something for us. What should it do? It should say game over. So game over. Then the game will be over. Done. Else the game should keep playing. So keep playing. So there's also some form of, let's say, the pseudocode
we write some pseudocode with some aspects of programming language and some short forms of like the programming language, the human language. So we can say something like int representing integers, we can say something like str representing strings, we can say something like the bool representing booleans. And the boolean are, these are all data types. So the boolean is having a value of true or false, so it can be used in a condition. We have these strings, we have these integers, we also have floats. So we have the float, and the float can also be used like the decimals. So you can say decimals, by programming. You don't have to say decimal, you have to say it float. So these are some things that we also use in the pseudocode. Okay, so with the flowcharts are also the means of representing algorithm in the forms of symbols and signs. So we can represent algorithms by forms of symbols. So in representing them with the symbols, we have the start, we have the input and the output, we have the processing, we have the decision, and we also have the flow lines. So the flow lines shows the direction of the code, or where the condition are, or where the process must follow, or the outflow of the code, or then the instructions where it must go. So if it's moving from the start, it should move to the process, or it should move to the input for requesting the data. Then it should also pass it to the decision, or how you're going to arrange your code. So this is also a means of representing algorithm. And let's look at the example. This is a simple algorithm to find the greater age. So we started the algorithm and we initiated, or we processed Kofi to be equal to 21 and Abner 20. And when it came here, the flow lines directed the condition, the statements to this condition to check if Kofi is greater than Abner. Then we have the yes, then we have the no. So if it is yes, it will follow the flow line to this direction. Then when it comes here, it prints. So this is the print box, or the print symbol. It prints Kofi is older. And if it's false, it also comes here, follow the flow line to this print box, say Abner is older. And they are all directed to the same end. So the program should start, then the program should end. So this is the flow chart, and these are the symbols that we use in representing the algorithm of a flow chart. So that's basically how we represented the algorithm in a flowchart form. So that is the form of representing algorithm. We have the simple language, or the human language, we have the flowchart, we have the pseudocode, which uses both human language and some programming concepts, and we also have the flowchart. So these are also the means of expressing algorithms. So in the next video, we're going to learn how to create our Python files, and also how to run Python from our terminal in our text editor. So the text editor that we're going to be using for this tutorial is the Visual Studio. So the Visual Studio is very nice, and it's very easy to use, it's beginner friendly, and it's also powerful. So thank you for watching this video.